The sizing requirements for neutral conductors in commercial buildings are found in National Electrical Code Article 220.61. For linear or non-harmonic loads such as lighting, heating, and motors operating at 60 Hz, the neutral conductor must be sized as follows. For a two-wire, single-phase system, the neutral equals 100% of the ungrounded conductor size. For a three-phase, four-wire system, the neutral equals 70% of the ungrounded conductor size. And for a three-phase, three-wire system, the neutral equals 100% of the ungrounded conductor size. In a commercial building with a 200 amp panel and no harmonic loads, assuming we're working with a three-phase, four-wire system, the ungrounded conductor size is 200 amps. Therefore, the neutral conductor size would be 70% of 200 amps, which equals 140 amps. Therefore, the neutral conductor in this case would need to be sized for 140 amps. Let's delve a little deeper into the specifics of neutral conductor sizing as it relates to the National Electrical Code. The NEC provides comprehensive guidelines to ensure electrical safety and proper functionality. It's crucial to understand these guidelines, especially when dealing with commercial buildings that typically have more complex electrical systems than residential ones. When we talk about neutral conductors, we're referring to the conductor that carries the unbalanced current back to the source. In a balanced three-phase system, the neutral current is ideally zero. However, in reality, loads are rarely perfectly balanced, and the neutral conductor handles any imbalance. Article 220.61 in the NEC is the key section for determining the minimum size of the neutral conductor. This section takes into account different types of loads and system configurations. As previously stated, for linear loads, like standard lighting, heating, and motors operating at the standard frequency, the sizing is relatively straightforward. Firstly, in a two-wire single-phase system, the neutral conductor must be the same size as the ungrounded conductor. This is because the neutral carries the full current of the circuit. If the ungrounded conductor is rated for 100 amps, the neutral must also be rated for at least 100 amps. Secondly, for a three-phase, four-wire system which is common in commercial buildings, the NEC allows for a reduction in the neutral conductor size. The neutral only needs to be 70% of the unrounded conductor size. This reduction is permitted because, in a balanced three-phase system, the neutral current is theoretically zero. Even with some imbalance, the neutral current is generally less than the phase currents. However, it is crucial to consider harmonic currents, which we will discuss later. Thirdly, in a three-phase, three-wire system, the neutral conductor, if present, must be sized at 100% of the ungrounded conductors. This configuration doesn't benefit from the potential reduction allowed in four-wire systems. Now, let's revisit the example of a 200 amp panel in a commercial building with no harmonic loads. Assuming it's a three-phase, four-wire system, we calculate the neutral conductor size as 70% of 200 amps, which equals 140 amps. This means you would need a conductor rated for at least 140 amps for the neutral. It's important to note that this is the minimum requirement. You might choose to use a larger conductor for various reasons, such as future expansion or to reduce voltage drop. Now, let's talk about harmonic loads. Harmonic currents are non-sinusoidal currents that are multiples of the fundamental frequency, which is typically 60 Hz in the United States. These currents are produced by nonlinear loads such as electronic devices, computers, and fluorescent lighting with electronic ballasts. Harmonic currents can significantly increase the current in the neutral conductor, even in a balanced three-phase system. This is because certain harmonics, specifically the odd triplet harmonics like the 3rd, 9th, and 15th, add up in the neutral conductor instead of cancelling out like they do in the phase conductors. When harmonic loads are present, the NEC requires you to increase the size of the neutral conductor to handle the additional harmonic current. The specific requirements for sizing the neutral conductor with harmonic loads are detailed in NEC Article 220.61c. This section requires you to determine the expected harmonic current and size the neutral conductor accordingly. One common approach is to use a neutral conductor that is the same size as the unrounded conductors, regardless of the 70% allowance for linear loads. In some cases, you may even need to upsize the neutral conductor beyond the size of the unrounded conductors if the harmonic content is particularly high. It is absolutely crucial to use a true RMS ammeter to measure the actual current in the neutral conductor when harmonic loads are present. This will give you a more accurate understanding of the current the neutral conductor needs to carry. If you don't account for harmonic currents, the neutral conductor can overheat, leading to insulation damage and potentially a fire. It is also important to consider voltage drop when sizing neutral conductors. Voltage drop is the reduction in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of the electrical system. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, you can increase the size of the conductor. This reduces its resistance and allows it to carry more current with less voltage drop. When calculating voltage drop, you need to consider the length of the conductor, the current it will carry, and the conductor's resistance per unit length. You can use voltage drop calculators or consult NEC Chapter 9, Table 8 to determine the appropriate conductor size. In addition to the NEC requirements, local electrical codes may have additional requirements for neutral conductor sizing. It is important to check with your local electrical inspector to ensure that you are complying with all applicable codes. The type of insulation used in the conductor also affects its ampacity, which is the maximum current it can safely carry. Conductors with higher temperature ratings, such as those with THHN or XHHW insulation, can carry more current than conductors with lower temperature ratings, such as those with TW insulation. The NEC provides ampacity tables that list the allowable ampacities for different types of conductors based on their size and insulation type. When selecting a conductor size, you must ensure that its ampacity is sufficient to carry the expected current. You should also consider directing factors, which reduce the ampacity of a conductor when it is installed in certain conditions, such as when it is bundled with other conductors or when it is exposed to high ambient temperatures. In summary, sizing neutral conductors in commercial buildings requires careful consideration of several factors, including the type of loads, the system configuration, the presence of harmonic currents, voltage drop, and local electrical codes. By following the guidelines in the NEC Article 220.61 and consulting with a qualified electrician, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes. Remember that the example we discussed, a 200 amp panel in a 3-phase, 4-wire system with no harmonic loads requiring a 140 amp neutral conductor, is a simplified scenario. In real-world applications, you need to carefully evaluate all of the factors mentioned above to determine the appropriate neutral conductor size. Furthermore, documentation is key. Maintain detailed records of your calculations and conductor selections. This will not only help you ensure accuracy, but also provide valuable information for future maintenance and upgrades. Electrical systems are not static. Loads can change over time as new equipment is added or existing equipment is replaced. Periodically reviewing your electrical system and verifying that the neutral conductor is still adequately sized is a good practice. Technology is always evolving, and so are electrical codes. Staying up to date on the latest changes to the NEC and other relevant standards is essential for any electrician or electrical engineer. Continuing education courses and professional development opportunities can help you stay informed about the latest best practices. By understanding the principles of neutral conductor sizing and staying current with the latest codes and standards, you can ensure that your electrical systems are safe, efficient, and reliable for years to come. And in addition, always remember safety first. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others. Wear appropriate personal protective equipment, such as safety glasses and gloves, and always energize circuits before working on them. If you are not comfortable working with electricity, it is best to hire a qualified electrician.